Hello everyone, I'm Daniele Gedalia, sales engineer at Optotune. And today I would like to give you an overview about what Optotune does, what our liquid lenses do, which challenges we solve, and provide you with some examples from the field about challenges which we've successfully solved. So with traditional optics, usually the working distance range is limited by the depth of field, meaning that there's a specific working distance at which you can focus. And if you want to extend the depth of field, there's different strategies that people usually adopt, either to increase the F number, meaning reducing the iris, which can work up to a certain extent because you might lose resolution or you might need a higher exposure time. You might add more cameras and more lenses in your system, which might be cumbersome to integrate and even a bit expensive. Or you might rely on conventional optics, basically mechanically moving optical elements, and this might be too slow for certain applications. And a real use case where this challenge shows up is in logistics or barcode reading, such as in this case, where you can only be in focus at a given working distance at a single time, which means that in cases of very fast conveyor belts with packages at different heights or different sizes, you might not be as fast as you want to basically refocus and successfully catch the barcode that you want to read. On a different scale or different use case, in applications where you might want to use high magnification telecentric optics, such as in semiconductor inspection or die bonding inspection, the higher the magnification, the shallower the depth of field, meaning that, as in this case, you might be in focus at a given distance, in this case where the wires are bonded, but in the background you might lose focus on other electrical components. And Optotune solution enables to basically overcome this intrinsic compromise that one has to make by basically providing a variable working distance range without any mechanically moving element in a few milliseconds. And all of this can be done by keeping a shallow depth of field and a low F number. And later on I will explain how this works. But as you can see, we can basically keep the shallow depth of field and refocus over a very large working distance range in a matter of 10 milliseconds. And again, I want to provide some concrete evidence of what I just said. In the field of logistics and barcode reading, a company that some of you might know, Cognex, has successfully now since several years integrated our small liquid lens in their barcode readers, and this enables very fast refocusing for barcodes that are positioned on the surface of packages that can be very small or very large, and this enables them to have a massive increase in throughput. And focusing on the second example, which I provided in the previous slide, in the field of electronics or semiconductor inspection, we have several customers that integrate the liquid lens to increase the depth of field or the working distance up to 100 times. And this specific example shows that a customer was able to reconstruct an all-in-focus 3D stack with a super shallow depth of field. So basically high resolution, but at the same time, very, let's say, enlarged depth of field or working distance range. So now that I've provided you with some real use cases and challenges that we help solving, I would like to quickly, on a high level, provide an explanation of our technology works. So just like our human eye are able to change basically the shape of our lens, Optotune liquid lens changes the shape of a membrane, of an elastic membrane, which encapsulates a special optical liquid in a matter of a few milliseconds. And this enables refocusing. And how we do this relies on a special electromechanical actuation principle, which some of you might have studied at school, the Lorentz force, so the interaction of electrical current with a magnetic field. So depending on how much electrical current is sent to the liquid lens, we can very fast and very accurately change the shape of the liquid lens. And some of the key specs that I want to highlight here is the ability at Optotune to manufacture lenses from very small clear apertures all the way to 50 millimeters, and this can enable us to target use cases spanning multiple applications. The fast response time of about 5 milliseconds. The low dispersion of the optical liquid, meaning that the index of refraction of our materials will not change much from the visible all the way to the shortwave infrared. The lack of friction in this basically actuation principle which I described enables this lens to be actuated for several billions of cycles, and this is key in high throughput, high duty cycle applications on an industrial level. And last but not least, for applications such as semiconductor inspection or metrology, we have proved that we can be very repeatable up to 10 millidiopters, which means that you will never lose focus for what concerns the depth of field of the optics where the liquid lens is integrated. So this is just a snapshot of the electrical lens modules which we provide for machine vision applications. So Optotune manufactures and designs liquid lenses, but when it comes to the final product, we also offer solutions which can be basically plug and played by our customers, because they are entocentric or telecentric lenses already integrating the liquid lens. And as you can see, this encompasses image circles ranging from S-mount solutions, so 1/2.5, all the way to TFL mount sensors, so a very wide range of image circles. And depending on the application, you have a list of focal lengths ranging from 5 all the way to 80 millimeters. And yeah, basically, we have over the years developed a very comprehensive portfolio that enables customers to find the right liquid lens no matter what the final application is. And as you can see, to make this electrical lens modules, we rely on a list of liquid lenses which we have ourselves developed. And to manufacture and to design and to release on the market these electrical lens modules, we have built a trusted network with some of the most reputable companies in the machine vision ecosystem. I will not go over the list, but you will recognize for sure most of these names on this slide. And this obviously enables us to deploy on the market electrical lens modules which have very great performance when it comes to the optics, but also when it comes to the mechanical design. So obviously the liquid lens and the lens module is one part of the equation, but the other part of the equation is the liquid lens controller, because as I mentioned in the previous slide, our lens works with electrical current, and to use the liquid lens and to refocus, you need a source of electrical current. So what we provide next to the liquid lens is a range of liquid lens controllers, which basically can be selected depending on the use case. So if you use our liquid lens in R&D applications, for example, and you only need one liquid lens at a time, you have a one-channel controller, which relies on a USB interface. But for more industrial applications, we have a 4-channel controller, which provides us multitude of interfaces such as Ethernet, UART, I2C, and so on. And something that we have recently deployed on the market is this embedded controller. And one of the main advantages of this embedded controller is its ability to be connected directly to selected camera companies in a way that customers can use the software of the camera directly to control focus. And this can be attractive and beneficial to customers that want a very integrated solution. I will provide more examples in the next slide. And obviously, we also provide SDKs, such as in C# and Python, for customers that want to integrate liquid lenses in their, let's say, softwares or applications. So what I was previously describing is the following. For many years, if you wanted to use a liquid lens, you needed a separate interface, meaning that you would have one interface for the camera and one interface for the liquid lens control. Now, what is possible with selected camera companies, and hopefully this will increase in the future, is the ability to connect the GPIO connector of the camera with our lens through our embedded controller, in a way that you don't need a separate interface to control the liquid lens. And this is now available with camera companies such as Alight Vision, Basler, and Opto Engineering. And I'm sure that some of these companies are showing some demos of this kind here at the Vision Show. So I want to conclude by providing just an overview of typical applications where our liquid lenses provide benefits and help solve challenges. So when it comes to our fixed focal length lens modules, these are usually used in high throughput industrial assembly or application or inspection applications. And usually the problems and challenges that we help solve in these situations are different products that are on the same production line, but they might have different heights, and customers sometimes want to use the same production line to inspect different products. Maybe with conventional focusing, there would be not enough time to refocus on objects which have different heights. It might be inconvenient to change the focusing relying on a human operator, or it might be too expensive to integrate multiple cameras on the same production line. And if you use our liquid lens modules, you will benefit from millisecond fast refocusing from a working distance of 150 millimeters all the way to infinity. You will not need any human operator. Actually, you will be able to remotely operate our liquid lens. You will not have any added vibrations coming from the actuation of our liquid lens. As I mentioned before, depending on the sensor that the customer is using and on the desired field of view, you will be able to select focal lengths ranging from 6 all the way to 80 or even 150 millimeters. And even for very high resolution sensors, our lens modules support pixel sizes as small as 2.4 microns. And all of these challenges basically can show up, for example, in food and beverage, inspection of pipes and profiles, but also in applications such as smart desks, where operator progressively assemble objects which grow in size and you need refocusing as this proceeds. And last but not least, I would like to show some similar benefits that you might encounter using telecentric lenses, such as in semiconductor inspection and bonding, electronics and pick-and-place machines, or even in pharmaceutical and life science applications, where usually the higher the magnification, the shorter or shallower the depth of field is. In the semiconductor industry, time is directly linked to money, so the higher the throughput of the inspection and the higher the revenue and the lower the cost. So conventional focusing might sometimes be too slow for these applications. And in applications in pharmaceutical industries, such as cell counting or morphology inspection, basically, the shallower the depth of field, the smaller also is the volume where you can inspect and count the cells. Again, similar benefits coming from our liquid lenses. We can increase the depth of field up to 100 times in a few milliseconds. The magnification change is very low and predictable, so this can be compensated in the software. The repeatability is enough that is well within the depth of field of the optics. Again, no vibrations, and this is especially important in very high magnification scenarios. And we have a very vast range of magnifications and sensors which we support from 0.1x all the way to 10x. So with this, I was actually a bit too fast. I hope that I could provide you with a clear enough overview of what we do, and if you have questions or curiosities, feel free to stop by at our booth. I think it's G25 in the hall 10, and yeah, if you have any questions, feel free to ask.
Any questions? Thanks, Daniel. That's really useful. Any questions? I've got a few, but got one over here.
So you're asking if you focus, if you need to keep the power going. Yes, our technology needs power to be flowing to the lens to keep the desired focal power, yes. Maximum is 1 watt, but usually in machine vision applications, you actually don't need the full diopter range that the liquid lens provides. So 1 watt is usually like the very extreme focal power. You can actually use much less than that for typical machine vision applications. Yeah. So he's asking whether liquid lenses introduce any additional aberrations or defects that normal optics might not have. The answer is, if the optical design is properly done, which is always the case when it comes to the electrical lens modules, then we actually have test reports on our website which show the comparison of the resolution with and without the liquid lens in the optical path. And in the vast majority of use cases, the resolution is exactly the same.
Yeah. Okay. Well, I think that's really interesting. I was quite excited when I saw your press releases coming out with the integrated camera control, with the Alvium and the Basler cameras, and that's all under GeniCam. And I don't know where you are, but there's a standard that's being developed by the EMVA, the Open Optical Interface Control.
Yeah.
So this is all becoming general, easy to use within your camera control GeniCam.
Yeah, so what I like to use as a word is ecosystem. Like this is progressively becoming a part of the ecosystem where like these camera companies will just use the standard GeniCam interface. So there's not going to be a lot of software development needed from the final customer.
I know when we were working with the project and it was the USB controller, you had to write the software, control the controller, and now it's all in the camera, easy to use. And I'm assuming that the one question we haven't done, you adjust the focus, but you need to know what you need to adjust it to. So I presume you use some sort of like laser depth controller or something like this?
It depends. At our booth, we have a demo where we use a distance sensor, which sends a voltage to our controller, and directly we can focus at the right working distance. But in some applications, you might not know where the best focus is. So we have autofocus routines already integrated into our SDKs.
Oh, wow.
So they are contrast-based routines. So basically, you can take, let's say, 5 to 10 images, and in roughly like 100 milliseconds, you might get what the best focus is.
Well, that's even nicer because you haven't then got to get a laser depth focus.
Yeah, it depends. Obviously, if you need to be super fast, it might be useful to have a distance sensor connected to our controller to directly focus at the right working distance, but it's not needed.
So the controller actually has a distance input, like an analog input? No?
Exactly. So the controller has an analog 0 to 10 volt pin, which you can use to calibrate or to map a 0 to 10 volt signal to a range of focal powers.
Wow.
And this can be customized by the customer. So if a customer only needs a certain range of focal powers, they can, on the software, calibrate this and save it on the memory of the controller, and then use it during operation.
Fantastic. We've got a question over there.
Yeah, so the sir here asked what's the wavelength over which we can transmit. So both the liquid lens and the membrane are highly transmissive, so well above 90, if not 95%, from roughly 400 nanometers all the way to 2000 or even a bit above that. So when it comes to transmission, then it depends on the coating that is applied on the cover glass of the lens. And as standard, we provide extended visible and extended NIR, but we can also do custom coatings. That's not like a limitation of our technology, it's just a coating which is applied on the cover glass of the liquid lens. This is the most secret part of our technology, so we cannot say what the composition of our liquid is.
Okay. This guy over here, another question?
So distortions, you mean like... So we actually provide the Zemax model of the liquid lens. So actually we also have a webinar and some documentation which shows how to correctly take the Zemax model of the liquid lens and integrate it into more complex Zemax models. So this will enable you to do tolerance analysis. So you will be able to see how the liquid lens behaves within a larger optical system.